that's the main topic starting now, pretty much until the end of the course. Surprisingly, there is a lot that goes on there, and so that's something that we should Before I go forward, are there any questions? Okay. So, so this you've seen before, right? In the very beginning of the semester, we talked about the fact that you can have different kinds of objects over which you're doing search. You can just have a generic web page containing text. You can have an employee record, which is more the purview of databases, or a movie review, which has partial structure and partial unstructured text. Okay, because movie review will have fields like the name of the movie, the director, etc., which are structured parts, and then what I think about the movie, which is unstructured. Okay, so basically, the one question is that, so if you are trying to do, this is sort of what we have handled till now. We looked at unstructured text, and we were trying to do keyword search on that. And we are trying to handle things like, if there are multiple unstructured text documents, some of them are more trustworthy or more relevant than others. And so that's what you try to figure out using link analysis. Okay. And then this is sort of what you would have done in database courses if most of you probably did databases, right, at some point of time or other. So in databases, you will essentially use tabular data with a particular structure. So there's a schema that describes the structure of the data. And then you can write SQL. If it is a relational database, then you can write SQL queries on the data. Now the interesting thing is you can do keyword search using SQL, but you can do a lot more than that. Okay? And then so there is a middle ground. So these two used to be completely different areas. This was, IR, and this was databases. Okay, but then there is more and more data which actually which has partial structure. In which case, you sort of need to be able to use both the technologies. And furthermore, in fact, you could somehow find structure in this unstructured data and specify it. And if I were to specify the structure in unstructured data, then I might be able to use something more closer to SQL style query. Okay, it may not be like a great life aim to be able to support SQL style querying. It looks like a boring thing to do in life, but compared to queries on keywords, SQL queries are much, much better because you can ask a lot more things. Okay. Okay. So this is what we looked at last time, and then we want to be able to sort of mostly interested in the semi-structured data, and we also and then that even a little structure goes a long way, and in fact we've seen that even HTML tags in the web pages can be used. Right? We use the HTML tags in the web pages to, for example, impose intent on the part of the user, saying if you put this in italics, maybe you meant those words to be more important than other words. Okay, and so I can give them a little more weight in the retrieval. Okay, so any structure that is available can be used, and you also saw that this part we mentioned that you can mostly do keyword queries if you just have unstructured text. You can do pretty interesting queries like give me the social security numbers of all the employees who have stayed with the company for more than 5 years and whose yearly salaries are 3 standard deviations away from the average salary. I realize that there are not that many lay web users who would ask these kinds of questions. Okay, but these kinds of questions are just important too. If you have structured data, you can actually pose these questions and get answers to them. This is, you can write this in a SQL query if you have relational data. Okay, and you can also ask questions, if you have part of the data is structured, then you can say, give me all the mails from people from ASU written this year, which are relevant to get rich quick, which is sort of in between this and that, right? So this was what we talked about structure, and the question, of course, in using, and presumably, if you want to be able to support these kinds of queries, you need to be able to exploit structure. Okay, you can't just assume that the text is English. Okay, you need to be able to understand the structure in the text. Okay, so you need first languages for specifying the structure in the data. Okay, so if I want to say, for example, that the movie review is not all text, there are some structured fields followed by the review, there should be some way in which I can specify to a machine that these are the field names, this is the value, the field name value, followed by text. When you look at a movie review, normally it would say director in bold letters and maybe the name of the director in italics, etc. So you see it already, okay? But a machine, probably to make life simple for a program, you might want to provide some formal way to specify the structure. And most of you are probably already thinking XML, which is actually what you use, but we'll get to that in a minute. Okay, for specifying the structure, if you know the structure and you want to specify it, you need a language for specifying it. And XML is a language for specifying structure. Okay, so if somebody wants to specify it, even if they want to specify it, there should be a way in which they can do that, and XML is that. Okay, and then also things like semantic web languages with C are also ways in which you can specify even more deeper structure. Okay, this all becomes clearer as we go on. Okay, the next thing is, if nobody is willing to give you structure, and you still want to support better querying than keyword querying, then you should extract structure from the text yourself. You, the search engine, should extract text from the extract structure from the text yourself. Right? So, if people are giving the structure, you need a language for them to write it in. That's XML. Okay? If they're not giving it, you want to extract it. First you extract it, and then you can write it in XML yourself. Okay? But this is an entire area which is basically, so for example, if I were to give you a review page, okay, saying director, the italics names of the director, and then the movie name, etc., followed by a paragraph of text, I should be able to write an extractor program which then realizes that director is a field name and the value right after that, skip, and then take the next couple of words, that would be the director's name. And then similarly, movie is a field name, and the name that occurs after the double colon is the name of the movie. This is what you're doing when you're reading these reviews. And then you see this paragraph of text and you say, it's the whole thing called review. Okay, and that part you probably only want going to do keyword-based search. Okay, so you need an extraction program. Sometimes extraction programs will be simple enough, such as you can easily see there's like a colon right after the field, and then the value of the field starts, and so you just need to write a program that kind of translates this. Sometimes it's not as obvious because they may have written the whole entire review in some sort of a flowing text. This movie, which was directed by the famed director, blah blah blah, that's a little harder. It's easy for you to figure out where the director is, but now if a machine is if a program is looking at this piece of text, for it to extract the part that director of this movie is this name, is sort of going closer and closer to NLP, natural language processing. Okay, so information extraction, we'll get to it a couple of classes from now, and information extraction is really, as I said, IR is poor man's NLP. You don't need to know anything about the grammar or anything and still try to act as if you can retrieve English text or whatever natural language text. Information extraction can be thought of as a middle class man's NLP. Okay, again, you don't need to wait for the full entire natural language processing enterprise to be complete before doing information extraction. So it tends to do little more than what IR does, and it's able to extract some of the structure. And the beauty of it is, every little structure helps you improve your querying ability. So you don't need to wait for the full entire meaning. I mean, if you can give people useful information without knowing anything about what is in the document, that's what you're doing when you're doing keyword search. right? Then any extra structure I throw it at you, you can only improve the ability, your ability to provide more useful information. Okay, so that's one, the technique for extracting information. These are challenges for actually specifying it, but you also have challenges for actually using the structure, which is then mostly sort of related to database style ideas. Okay. In fact, the more interesting point, let me see here. Maybe I have it here. So this topic, the main topic that we're going to be talking about for the next several classes, you want to find, represent, and exploit structure. That's what you want to do. Okay. So getting the structure, you want to allow structure specification languages. And XML is a structured specification language. Semantic web languages provide even more structure than XML. That becomes clear in a minute. But for example, if you have a file, about a book which has a tag called author, and another file about a book which has a tag called writer. By the way, if those of you have never heard of XML, what I said probably didn't make sense to you, but several of you probably heard of it, so it made sense to you. But I will give you XML syntax in a minute. Okay? So now here's a writer and here's an author. Most of you think they're the same. Writer and author must be the same. But a program doesn't know, it's just two different tags. So somebody else has to write another piece of knowledge on top of this, saying a writer tag is the same as an author tag. Do you see what I'm saying? That's the kind of thing RDF and OWL standards will provide. Okay? And then if as I said, if the structure is not explicitly specified, or sometimes it's actually obfuscated. So one of the interesting things that happens on the web is a lot of web pages are really databases. They actually have data written in some relational databases. And when you ask a query in keywords, they will then capture that query, write it into SQL form, send it to the underlying database, get the tuple out, and since they think you only understand English, they will write it into some sort of pidgin English. So for example, if I say, what is the capital of India? Okay, so some particular database which has entire table of countries and capitals might realize that, okay, New Delhi is the capital of India. And then instead of just giving New Delhi, India, it might then put it into the capital of India is New Delhi, period. And I feel good because this thing is talking to me in English, right? But in some sense, my IR program is feeling bad because it wished that it was given a tuple, not some arbitrary English piece. So here the structure was obfuscated. Do you see what I'm saying? What you really want is a direct API access to the database, which you get. For example, if you have understanding with Amazon, sometimes you can get API access to their database directly. If you don't, then you are sort of screen scraping. Okay, you're looking at, they assume that their screens are read by people, and so they already convert it into some sort of English. And then if you actually want to convert it back into their data form, into the tuple form, then you sort of need to pick this piece and construct a tuple. That too is information extraction. It's a much simpler kind of information extraction because originally this data had structure. Somebody just obfuscated it poorly, and you should be able to get it back. So sometimes these kind of extractors are called wrappers. Okay? And I don't know why they're called wrappers, they should be called unwrappers because you took structure and put some random English words in between, okay? And you are unwrapping it, removing the random English words so that you just have the tuple, okay? So the wrapper technology is a form of information extraction technology. It's the simplest form, essentially, okay? And so anyway, so if it's not specified, so that you should be able, if either the structure is not explicitly specified or it was there before but it was obfuscated because the provider thinks that it's humans who are reading it and they would want it to be in some sort of a natural language, then you still need to convert it back, okay, if you don't have API access. And for those, you do wrapper generation and information extraction. We will learn about that. Okay, those are the two things. Now, after you get the structure, you would like to use the structure. Okay, in some sense, you know when we got into this that if you have structure, you can answer more interesting queries. By the end of this lecture and next several lectures, you would learn to hate the word structure because I would say it so many times. But try not to hate it. Okay. For retrieval, for example, if you just want to retrieve, you can start from the IR side and use the structure to improve the retrieval. You already saw that to some extent from like HTML tags can be used to improve. And we'll see some more today, for example, path-oriented queries on XML files. Okay? And then you can also, on the other side, from the database side, you can actually start from the database side and use the structure. The tricky part is while IR has no structure and so it has to learn to exploit the given structure, databases assume full structure. What you're going to be able to give them is partial structure. So for them it's a fall from heaven, or heaven of structure. Okay? So it's not all database techniques are not going to just work out of the box if you only have partial structure. Do you see what I'm saying? So it's actually an interesting research challenge for both IR and databases. Okay, database guys have to learn to live with less structure. IR guys have to learn to exploit more structure, and they will, meet in the middle and shake hands or something. Okay, so that's the kind of issues that we'll talk about when we are talking about exploiting the structure. Okay, and then furthermore, there are interesting issues in terms of exploiting the structure across multiple sources. Okay, because again, just like it's one thing talking about one page and another thing talking about multiple connected pages, in the way you have to do things like link analysis. So here, if you have multiple structured pages with their differing structures, then you want to first align the structures. Okay, so you have to integrate information across sources. So for example, if there's one page which gives capitals of, one page which gives weathers of cities, another page which gives capitals of countries, and I want to know what's going to be the weather in the capital city of a country I'm going to, then I need to sort of join these two pieces. Joining is fine if one single person has decided the entire schema for all the sources. If not, you need to align the sources correctly and answer. Those become the information integration issues. Okay, so those are the issues. Structure, using the structure, getting the structure will get you information extraction and XML, and then using the structure will get you information integration. Okay, that's the idea of the rest of the semester. Okay, and so what I'm going to do first is this, and this, and this. Okay, so if you're lost, come back to this slide. That's like questions. Yeah.
You said basically we are taking unstructured data and trying to give some structure to it. My question is this specifically for getting more relevant results or increasing the recall, or can you also use it for ranking? Since you are
Everything. Everything. So the question is, you can improve ranking, you can improve relevance, you can improve recall, you can also improve. So for example, had I asked this question to Google, right? What do you think its answers will be? What? Mostly irrelevant. Okay, so it's like you're talking about, so you will bend over backwards to give it some points. At least you tried, But really, you are not getting the answer for the question you asked. And if you have the structure, and you cannot get the answer to this question unless you have the structure. So there are, in fact, more interesting questions. So you're asking from the point of view of keyword search on the web. There, the precision will improve, the recall will improve. And of course, precision and recall improve because ranking improves. Okay, but you can also go to something like this. You can answer questions rather than telling people, go look here, you may have the answer for your question.
So we will be taking care of a part where we are actually converting this into a query which can be.
That's a good question as to who is going to ask. So that's actually, so the point about asking difficult queries like this is, again, please understand, that much of this technology doesn't have to be. I know most of you came to this course only because you wanted to understand what Google does and nothing else, no more, no less, okay? But most of this technology is also relevant, okay, to people other than just lay web users. Oracle also is a company, okay? Oracle was basically living in this world of full structure, and they have to learn to live in the world of partial structure. And they have people who will write 3-page SQL queries. I understand you have no web users who will write even one-line SQL query. Okay, so your point is well taken that if I can support SQL, so I'm a database, I can support SQL. I put myself on the web and I wait for people to ask me SQL queries. And I wait, and I wait, and I wait. Nobody's asking me SQL queries. So then I realize that they're going to ask me keyword queries. I have to convert them somehow into some sort of SQL and answer them myself. And I realize that most of the time the keyword queries they ask are not going to be, completely specifying a unique SQL query. So there's this issue of how to convert a keyword query into close enough SQL query so that they will get the answers they want. So if you have structure, so in fact that becomes a very interesting question to people who have full structure on their databases, but they're stuck with users who don't want to ask structured queries, who want to ask. So structure is two-way street, right? I mean, you can have structured query. SQL is structured query language. Okay, you need people asking structured queries, and you want language, data with structure. Even if you have data with structure, your users might be lay users, and they just ask keyword queries. And then there's a very interesting direction of research as to how to support keyword queries on databases. We will talk about that a little too. Which almost sounds like, why would you want to support keyword queries on databases? But that's exactly because of what you said, which is, in the old days, databases were used by database managers and trained SQL hackers. Now databases are used by people like you. Not even people like me. Any lay web user who just asks a keyword query, and that query gets captured and a page gets dynamically generated as an answer. There the keyword query is being converted into some structured query, and it's being answered on the underlying database. Yes?
There's a program called Wolfram Alpha, which kind of does like, even the keyword, it has data in this like databases.
Yeah. No, I mean there are people doing this. I mean, Alpha, I know Wolfram Alpha does some of this, and even some of the other search engines do this. There are implemented systems for supporting keyword queries on structured data. Part of what we're going to try and do is understand how some of those things work. Okay, hopefully you understood how keyword search over web pages works. Now we can support other things. That's what we're doing. Okay, any other questions? Yes.
When we think about learning the structure of a document, do we just look at the content? Or do we look at any other?
All sorts of approaches are available. I just showed you the problem. There are a large number of them. I probably will touch a few approaches. Information extraction is a huge area right now. It's a huge area. Okay, you can bring any weapon you have to bear on the problem. The reason the part of minimum thing that you want to understand just by now is why information extraction is a huge area. It's because they are extracting structure, and structure improves query. Structure improves better results. Structure improves the precision and how we call it the results. Okay, so so this is topic 3 is what I'm going to look at, and I'm going to start with XML. So for the next several time, we'll talk about XML. Many of you probably know and heard of XML. Even you probably might see a different view of looking at XML because you're coming to XML as if it is this middle ground for specifying structure, specifying partial structure. That's what we're going to do. Okay, so XML is essentially a confluence of two factors. Basically, IR folks wanted some way of providing more structure in the text documents, or at least allowing people who want to give structure a way in which they can write that structure so that programs can use it. Database people wanted to learn to live with less structure. It's both, okay? And so XML is actually the answer for both of these issues, okay? So now, of course, original expectation is that there won't be any databases, there won't be any web pages, there'll just be XML everywhere. And you won't be taking a 471 course, you won't be taking at least first part of 494 course, you will take just an XML course, okay? But clearly that's not happening, okay? Because people are still writing web pages in their own languages, and people are also doing just fully structured data as a separate thing, okay? So it's partially useful. Many a time, one of the things that will happen is certain people, certain sub-communities might agree on standards for XML. In fact, we'll talk about why standards are needed for XML in a minute. And then they would then be able to exchange data, which looks almost text combined with non-text. And it will still be able to be used. The most famous example these days of XML is what? That every one of you have used. Guy with the laptop, unless you're using it for class, please leave. So, what's the most famous example of XML?
Newsfeed.
What?
Newsfeed.
What is that?
Like it's not easy.
I don't know what it is. I mean, yeah.
Is it taxation?
No, not that. I mean, you all are carrying these days data in XML from place to place. What? Have you written Word documents? Excel documents?
PDF.
Remember it used to be called DOC, now it's called DOCX. It used to be called .xls, it's now called .xlsx. Okay, .ppt became .pptx. What is it? You can actually open these documents now because they have XML structure. Do you understand what I'm saying? So essentially, Microsoft agreed upon itself, with itself, as to what the tags are going to be. And it wrote down all the tags that it's going to use. And so, and then they can write a whole bunch of programs now which can then easily read this data, which is what we'll see. So you all have used XML that way. Every Word document now is an XML file. Okay, it has come to that point. Okay, and one of the things we'll see in a minute actually is here. Okay, this is an XML document. Okay, so here I'm starting saying tag begin. Okay, actually let's see pieces of it first of all. So you have a starting of a tag, ending of the same tag. Okay, you have an element which is between tag to tag, and the element can itself have structure. Element itself is a sub XML element, right? So this one itself has structure sometimes and sometimes. Okay, you have attributes. Anyway, by the way, again XML standard. All I'm going to do is give you like a bit of the current standard. Okay. And talk about how it connects to our quest about specifying and exploiting structure. If you really want to know exactly what all can you write in XML, you should read up some manual somewhere. Okay, so you can have end tags. You can also have, in this case, a tag can have an attribute. For example, show with the year being equal to 1994. Okay, and then here is an interesting thing. Reviewer begin, Roger Ebert, reviewer end, gives. What is gives? It's not inside any tag immediately. So that part can be just language, normal language. So the interesting thing is, and so gives 2 thumbs up rating. So the rating is 2 thumbs up. And then here is again a fun action movie, Harrison Ford at its best, at his best. That part again is not tagged, it's just free-flowing language. This is what I said you will be able to do, right? XML can put, combine structure with non-structure. And here is, this part is unstructured and this part is structured. Okay? And you can imagine how you can write a mail document, a mail message, an email message as an XML file. Okay? You start mail begin, from begin, the name of the person sending it, from end. To begin, name of the person it being sent to end. And blah, blah, blah. And then body begin, and the body, and then body end. Okay, and obviously the other thing you can see is XML looks almost like HTML, because HTML also has tags. HTML is a sub-XML. It's basically the point of seeing, first of all, how can you tell whether a particular document is an XML or not?
Tags.
What?
Tags.
Why? I don't even have to have tags, it turns out. Everything is in XML. You see what I'm saying? Can you tell, for example, can you tell whether or not a document is in a list form? Well, everything is in list form. You can say first line is one item, second line is another item, third line is another item, then it will become a list. Okay, so the part of what I will do in talking about XML is to kind of completely make you realize that it's a total syntactic standard. A, it has nothing to do with meaning, and B, it doesn't put any constraints on anybody. Okay, about the only thing you can do is if you start a tag and if you did not end a tag, then somebody will say you are not a well-formed XML document. That's all. Do you see what I'm saying? So, but just because it's well-formed doesn't mean somehow it's more meaningful. It's just that if you started a tag, you should end it. Okay? So anything is actually XML, so is HTML XML. Okay? The question, of course, is what can you put as a tag? Anything. Can you put anything as a tag in HTML? No. Because the point is, in the case of HTML, the tags you use have meaning. And the meaning is in the mind of who? The renderer. Right? The browser. Okay? So if you wind up using random tags, then the browser won't know what to do with those tags. Okay? You guys have probably heard of style sheets, CSS style sheets. What do? They essentially take a normal XML file with arbitrary tags, and there is a translator file which says if this tag is present, then convert it to these HTML tags. And so then an XML file gets translated into HTML file. And then given it to a browser. Browser knows what to do with those tags. So in fact, you can think of style sheets as translating an XML file from one tag format to another tag format. And this is actually a form of query processing on XML files. We'll see that later. Now, when you are starting to think of what all you can do, what kinds of querying you can do on XML files, one of them is output data in a particular format. And style sheets actually do that. They'll convert XML file into another XML file. And if that second XML file happens to be HTML also, then you will be able to show it. If instead it converts into some other XML file that probably is supposed to, for example, there are two companies with two proprietary XML standards, right? Then you can write a translator which converts this guy's XML into this guy's XML. And neither of them can be shown by a browser, but you still did useful thing. You converted data from one form to another. Okay. So that's an example of XML. So you have the terminology here is there are tags, there is start and end tags, there is elements, elements can be nested. You can also have empty elements. You can start a tag and end a tag at the same time without it. And sometimes you can abbreviate it to this. Basically they're saying it's just, you're using it almost like a property of the file. The file has a red property. So you just start the red and end it. Okay. And then an XML document, a properly formed XML document has a single root element, and then you can think of the XML document structure as a tree structure. Okay? And then you have also attributes that can be, and then there's more interesting, you have namespaces. So you can have tags, with different namespaces. So namespace colon, the tag, can change. It's like packages in some languages. Okay, all of these are available. Okay. And then all a well-formed XML document means it has matching tags. If you began a tag, you ended it. That's it. The thing that you want to understand is XML doesn't mean meaning. It has no meaning. It's just you can randomly start a tag and end a tag. It becomes an XML file. Okay. So except the attributes we showed earlier to the year attribute here, book attribute has a price 55 currency USD. That's something that you can do. And then other thing that I don't know how many people use it, but it's part of the language. Is you can have object identifiers, and so you can refer back to the object identifiers. when you do this, then XML is no longer as a tree form because we can have pointers from descendants back to the ancestors in the tree. Okay, so in this particular case, you are saying the person has an ID, 055, and then the children basically, so the children is kind of referring back to this. So essentially, Mary's child is Jane. That's what you're trying to say. Again, that's what you read these English words, you impose meaning on these English words, and so you think, oh yeah, that means Mary's child is Jane. Okay. So again, voids and references in XML are just syntax. There is no actual meaning that's being attached. So this is what I meant by the tree structure of XML. So if you have an XML file like this, essentially it corresponds to the DOM tree. Okay, and that's like root element is starting with play, and the play has an element author, an element act, an element title, and then there is you can see the element author basically has some text Shakespeare, element act has an attribute number, and an element seed which has this structure and so on. So it's like a big file, big tree. Okay. One nice thing is once you realize, again, this won't be a tree, and it will have pointers, back pointers if you have object identifiers. We'll ignore that for now. Okay. One interesting question is now the data is a tree, so you can ask more interesting questions. Right? Because all you could do in keyword queries are at best either keywords or proximity of keywords. Now I can ask queries such as, show me the place where there is an element which has a sub-element, an element called act, which has some sub-element called verse, which has text will I with. So I should be able to then look at all the files and see which file has, satisfies this structure. It's not a proximity query. It's sort of a path query where the path is in terms of the tree structure. Right? We'll talk a little bit more about path queries later, but you can already see that because you have this tree structure, you can ask those kinds of questions. Now, of course, you can convert anything into XML just by putting a random start and end. And in which case, it will just be root element below which there will be a huge amount of text. In that case, you cannot ask any meaningful path queries because you didn't give any structure, which is what we wanted. If there is structure, you should be able to exploit it. If there is no structure, you should be able to live with it. Okay? Now, one interesting question about XML would be whether order matters in the XML file. Okay, the order being order in which the paragraphs are written, order in which the text is written, does that matter or not? Well, the interesting question would be, if you see XML file as a self-describing version of relational data, because in fact we'll see that we are coming to XML from IR. IR was talking about text. Text is always ordered. You can't just, although we use bag representations, you do know that underlying semantics of the text is if you change the word order, the meaning changes for the user. So XML should be ordered if you come to it from the IR side. But on the other hand, if you come to it from the database side, it should not be ordered. Because in a database, if you have a tuple T1 below which tuple T2, another database there is tuple T2 below which there is tuple T1. They're the same database. You see what I'm saying? So by database semantics, XML should not have order. And so database people actually would like to assume that XML files don't have order, just like. And one of the interesting things we'll see is, some of these querying standards, such as XQuery, that they provided for XML, will basically can live with either order as the assumption or unordered as the assumption. And you need to say upfront, do you want to see this file as ordered or as unordered? Yes, what's the question?
It's actually both. So the relationship is actually ordered, but when you want to look at the actual unstructured text, then it's no. The relationship is actually unordered, but if you want to look at the actual text, then it's ordered.
So what do you mean?
As in the case of the example that you gave earlier, one of the XMLs.
No, the text is basically you're talking about. So the point is, this text is ordered, is what you're saying. But the interesting question is that in a database point of view, suppose I have a tabular data, right? Okay, I'm kind of jumping ahead, but it's not. Suppose I have a database tabular data. Name, grade, right? Okay, that's my tabular data, and it just has name Sam, grade B. I hope there is no Sam here, and name Rav, grade C. Let's say. Okay, so that's the data you have. This is the tabular data you have. If I want to convert it into an XML, and I assume that the most obvious thing to do is to make the attribute names the tag names. Okay, so I would say name begin Sam and name, and so this is basically first the record is begin. So you can say tuple begin. Okay, and then grade begin. B and grade, right? Now that's one. The next one, nothing stops me from, and the second one, I can write it like this, tuple begin, grade, C, and name, Rav. I change the order of the tags, and you won't yell at me because the tags basically are just telling you. So changing the column, entire column, doesn't matter as long as I told you upfront. So databases don't have any order. Okay. So again, it's an interesting point to note when you see XML from the point of view of, you can, as I said, this picture. Remember this picture. We'll come back to it multiple times. So you can get to XML from text because you want to have more structure, and you anyway, if you're text, you want order anyway, and you can get to it from databases, in which case you're looking for partial structure. Okay. So in this case too, databases might allow partial structure. So for example, if I have, let's say, people who have more than one grade or more than So let me put it this way. Suppose I have a book field, and then I have title of the book and author of the book. Now the question is, how many authors do books have? Always one? No, sometimes two. Only two? No, sometimes three. Only three, maybe indefinite really. Okay? So from a database point of view, you need to be able to say, I have a table which has title and some number of author fields, where I won't tell you how many author fields are there. And some books have 4 authors, some books have only 1 author, some books have 3 authors, etc. So this is a data where not each tuple has the same structure. It's in some sense union of different structures. And that, from the database point of view, is losing, everybody following one simple structure. And you can write this in XML very easily. You put a star, author star. That means there can be author plus. That means there can be 1 or more authors for this book. And then you keep writing the authors' names until you're done. Okay, so that's what we'll again get back to that example later. But that's how databases are interested in XML because they allow partial structure to be specified. Okay. Okay. So XML and order is one thing. As I said, there is nothing default. You need to decide. If you are an IR guy, you would like order to be default. If you're a database guy, you want non-ordered to be unordered to be default. HTML versus XML, we talked about this. Okay. Really, HTML has a specific type of XML tags. Those are the tags which have meaning, agreed upon meanings to the renderer, to the browser. Okay. The other thing is that I also mentioned that if you have you can have data being shown these days mostly. You write the data in XML format, and then you provide a style sheet which will render it in any which way you want. By changing the style sheet, you change the way the data is actually displayed. Okay, but then when you're doing that, what the style sheet is doing is it is converting arbitrary tags into HTML tags. That's what you're doing. You're providing a translation between tags. Except this is obviously a non-meaning preserving translation, because many things will get mapped to italics, and they all are different tags. You can't redo the mapping back. There's no easy way of looking at an italic and say, oh, this must mean it's author field. Okay? So you can actually think of style sheets as doing some sort of a translation of XML documents. Okay, now the next question is, who puts everything into XML? Okay, what? Microsoft. so the point is that to a certain extent it's sort of a vacuous question. If anybody feels like putting some structure in their data, then you'll be able to use it. Okay, and the reason you would take the trouble of putting structure into data is because you want it to be more easily accessible to some other people, some other programs. Okay, so you can just put things into XML by putting body begin, body end. That becomes XML. Okay, and it's not meant to be an imposition, but rather a facilitator. Okay, if you want to do nothing about XML, you don't need to do anything. Whereas if you want to provide more structure, I will allow you. I'll give you a way in which you can provide that structure. Okay, so it's a facilitator. Okay, now as to who would put this structure, the creator of the page can put the structure. Okay, some secondary user might go and put tags on somebody else's page. So they are providing the structure for somebody else's page. An extraction program that may have extracted the actual structure in a text file and wants to remember it for the next time around so that it doesn't have to re-extract it. So it might remember it as an XML file. Okay, so there are many different ways, many different places where you wind up getting XML data. Okay. And then, as I said, markup tags may or may not have any specific meaning, and whether or not they have any meaning is based on whether there is a prior agreement beforehand. Typically, what happens is particular subsets of people or providers agree upon standards. Like, for example, all browsers agreed upon HTML standard. And they said, as long as you write your XML file in HTML standard, we can show it in the same way. Okay, that's the simplest case. But there's so many other people. So extensible financial reporting markup language, this XFR LML, I think. Extensible business reporting language, music language, space markup language, bank internet payment system. And then, as I said, Word is also in XML now. Word documents are stored in XML. Okay, in all these cases, they'll write an English manual saying when to use what tags. And nobody is checking whether you are actually using those tags correctly or not. You are supposed to read the tags, read the manual, and you have some data, you convert it into the tag form, and then input out into the thing. And so one of the advantages is actually, I think which one is this? The electronics XML, electronics small parts, electronics business XML initiative. I think that is the one that actually predated XML standard itself, and even HTML, because they needed a common language in which they can, essentially have a single program look at all the providers providing this part and see who is providing it cheaper, for example. Okay, so they developed a complex set of tags, and they understand between themselves what each of those tags mean. You don't know. Okay, but their programs essentially have the meaning hard-coded into them, just as HTML tags meaning is hard-coded into the browsers. Okay? Okay, so these subsets of people might agree upon communities that agree upon some tag standards, and then they just, nobody is still enforcing it. If you misuse the tag standards, maybe then your parts would not be sold properly, for example. That's the worst thing that can happen. Okay? So that's where the standardization occurs for XML. There is no web level standardization for XML. Nobody stops you from writing any random tag. Okay? So that's about the syntax of XML. What I'll do next before the end of the class, I think, and the two pieces, which is let's view XML from the IR side and do querying on it, and then let's view XML from the database side and see what you can do in terms of querying on it. Okay. Again, as I said, every one of these things. So this part, I think Professor Chen actually gives an entire course which is sort of related to an extensions of this whole idea of XML-based query processing. Okay. Okay. So why are IR folks excited about XML? Because they are text files with structure, and you should be able to ask more interesting queries with structure, or you should be able to take even normal keyword queries and improve their precision and recall because of the structure. That part you already did. The second part, because when you use HTML tags to say anything which is in the header tag has higher weight than anything which is in the footnote tag. When anything which is in the tiny font tag has lower weight compared to anything on the header tag, right? That is basically, you're still using keyword queries, but you're able to improve precision and recall just on the results for the keyword queries. That you have looked at. And so today we'll sort of look at if people are going to ask keyword queries with small extensions. They're not still willing to write a page-long SQL query, but they might be able to give, like, let's say, proximity queries that you already do, such as you say, this word must occur next to this word. You can do that already in the keyword system, right? Now you might be able to say this word must occur in this tag, in the fields, in this particular element. Those kinds of questions can be asked. Let me show you an example. So go back to this example, which we've seen before. Here are some path expressions. So the simplest, of course, is this one, which is give me, find this, this one actually is saying, basically that find Shakespeare occurring in an author element. That's what you want to ask. Okay, so here is a path expression which says ... author ... Shakespeare. Where the ... basically can be any part of the path. So as long as somewhere along this path there is an author tag, followed by somewhere at the end of the path there is a Shakespeare tag, a Shakespeare string, that path satisfies your query. Okay. Then the normal keyword query would be something like this: ... Adam and ... Apple. If you want to ask for Adam, Apple as the keywords. Okay, you just want both of them. Okay. Another path expression is play, act, scene, verse equal to will, I, will. So there's basically play, act, scene, verse equal to will, I, will. So that's what you're asking. So tell me a file which has this particular path occurring in it. Okay. Now notice that in the textual form of this file, these elements, these strings may not occur right next to each other. But in the DOM tree, they are in a path. So this sort of makes it a little more interesting proximity queries. So proximity in terms of tag structure rather than proximity in terms of physical proximity. Okay. Now, one thing, of course, is if in one file Shakespeare occurs under the tag writer, and another file it occurs under the tag poet, and another file it occurs under the tag author. And they're all files about, probably the creations of Shakespeare, let's say. Now the question is, your query, author Shakespeare, is it only supposed to bring you the paths where author will be where Shakespeare occurs under author and not under poet, and not under writer? Or do you also want to support these other ones? And if you want to support these other ones, there's no obvious way, because you should have known that writer also means the same thing as author. A poet is a kind of an author. That is relationships between tags. It's more meaning. Okay? XML doesn't allow you any standards on that. That's what semantic web standards give you. They will allow you a way of writing on top of the XML tags, relations between those tags. Okay? The other thing about retrieval, a few more issues on the retrieval over large XML files is one of the things is, so you have to ask yourself, are you only supporting keyword queries or also path queries? Okay? As I said, even if you're only supporting keyword queries, you can still exploit structure. Okay, you already know that keyword queries, or Google or any search engine will already know that in a file where the keywords occur next to each other is somehow more relevant than ones where they occur far away from each other. Even though you didn't say they have to occur next to each other. Right, the distance, the physical distance does matter. That's a reasonable heuristic. Okay, but now when you have XML, you can actually say that as long as they occur in the nearby elements, where it does no longer physical distance, but it's the logical distance in terms of the element paths. Okay, that way you can actually support higher precision even for keyword queries. But you can also ask path queries. As I said, I showed you some path expressions. Okay, now as to whether people will ask path expressions or not, that question that somebody had, we don't know. Okay, if they don't, then obviously they're not using the ability of the structured query. But somebody else might, and for them you can use that. Okay, so the same data can be used both for keyword queries and path queries. Okay, now what should be the results when you run something on the XML? That's the other interesting question. Up until now, we just assumed that when you run a query on the web, you get pointers to entire pages. Right? You get the URL for the whole page, not just the paragraph in which those queries occur. Okay, the paragraph in which where the queries occur might be sort of shortened into a snippet form when the search summaries are shown to you. But really, you get the entire file link. Okay. But one of the things is that with the XML, I can actually show you answers also, just as against giving an entire link to a file. Okay, when I'm showing answers, the question is, when I give a link to the file, that means I'm saying that the answer is the entire file. Okay, so if I have an XML file here, and you said, show me a file which has, show me, my query is, give me something about the grade of raw. Okay, so I will start with name, raw, that's all I say, name raw, and so I expect that you will give me the tuple for name of raw and the grade being C. That's what I'll expect. But a normal search engine will just say, well, raw and name occurs in this page, so I'll give you this entire page. That's like saying, I'll give you the database every time you ask a query. Which is what we are living with all this while, because we had no better way of doing it. And we are assuming that here is the database, go do your query processing yourself, is what we say right now. Okay? But in the database world, we'll be really mad if for every query the answer is the database. So if they just give the link to the database, you would not be very happy. And since XML is in the middle, it should be able to give you the results. What's interesting, of course, is in the case of databases, the structure of each tuple is uniform, because all tuples will have exactly the same number of tags and same number of elements. But normal XML doesn't have to have that. Normal XML can have any arbitrary nested element structure, which means you still need to figure out. In this case, it was obvious that if I said name raw, you should give me this part of the XML file. But if I have arbitrary nested structure, it's not as obvious. How much of the tree are you supposed to give me as the answer? Okay, so that's one of the questions. So do you give the entire XML file, which is what search engines do, just the smallest element of the XML that matches the query, And what if you have keyword queries and one keyword occurs in this element, one keyword occurs in this element? A reasonable thing is to go up the tree until you find the common ancestor, lowest common ancestor, and give that entire subtree as the answer. You just solved a problem. Okay, but the point is that problem is there, which you didn't have before. Okay, so this is one of the things that people have to think about when you have to support when you're doing queries on XML. The other interesting things, by the way, one interesting thing is how do you, if you want to support this on XML files, right? How do you index these? Remember, from the efficiency point of view, normal text files were indexed as to where the words were occurring. Okay, for each word, all the documents where they were occurring. My question is, you need to be able to do it efficiently, you need to again have an index for XML query processing too. So the first question is, without looking